Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2022. This paper is worth 120 marks in total, and this is the third video of 6. It will focus on questions 9 to 11, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 9. Below is a recipe to make a batch of 12 flapjacks. So this is the recipe and how much of each ingredient we need to make 12. Part A, complete the table to show how much of each ingredient would be needed to make 72 flapjacks. Okay, so we've got a recipe for 12. We want to be able to make 72 flapjacks. So I need to start off by dividing 72 by 12, which is 6. So I need 6 lots of this recipe to make this recipe. So I'm going to multiply everything in here by 6. So for porridge, we're going to do 240 multiplied by 6. For butter, 125 multiplied by 6. Notice that I'm writing these down as well as writing the answers down, because if I press something wrong on my calculator, which I do quite a lot, I'm showing them I'm trying to do the right sum. Even if I get the wrong answer, there's marks there for me, guys. Showing you're working out is important on a calculator paper. So sugar, so we're going to do 100 multiplied by 6. And then golden syrup, 2 tablespoons. So 2 multiplied by 6. We need 12 tablespoons. Okay. Part B. Natalie has 1.75 kilograms of butter and plenty of the other ingredients. What is the greatest number of batches of 12 flapjacks Natalie can make? Okay, so how much butter we have is the thing that determines how many batches we can make, because everything else we've got lots of. So we're working with butter, guys. So for 12 flapjacks, so up here, we need 125 grams of butter for 12 flapjacks, okay? So we will need 125 grams of butter to make 12 flapjacks. We have 1.75 kilograms, so let's change that. 1.75 kilograms is equal to, times by 1,000, guys. Oh, times by 100. 1,750 grams. So we have 1,750 grams of butter. Let's see how many lots of 125 we have. I couldn't do the division before because we had different units. So that's 14. So we can make 14 batches of 12 flapjacks. Part C. This note is written underneath the original recipe. To make 15 flapjacks, use 25% more of each ingredient. Show that this statement is correct. Okay. So the original recipe makes 12 flapjacks, okay? So the original is 12 flapjacks. If we want to make 15, we're wanting to make 3 more flapjacks than the original recipe makes. So we need to find out what percentage of 12 of that batch 3 is. So let's do 3 over 12 and multiply it by 100. I'm going to do that all in my calculator, guys, because a fraction multiplied by 100 gives me a percentage. So 3 flapjacks is 25% of the 12. So if we use 25% more of each ingredient, then it's correct. Question 10a. Simplify 5f, add 6g, add 3f, minus 9g. So this is collecting like terms, guys. So what I need to do is get a highlighter, and I need to highlight my terms that are like terms. So to be a like term, they have exactly the same letter and exactly the same power. So 5f and the plus 3f are like terms. I've highlighted the add that's in front of the 3f because that's important, guys. We also then have plus 6g, the sign in front of it stays with it, guys, and then minus 9g, the sign in front of it stays with it. So we have, in terms of the f terms, 5f add 3f, which is positive 8f. And then when we're dealing with the g terms, we have positive 6g, take away that sign in front, guys, take away 9g. 6 take away 9, do that in your calculator if you're not sure, is minus 3g. Now I'm going to write this as an expression, 8f subtract 3g. Part B, expand 5 multiplied by m subtract 3. So we're expanding brackets. Many different ways you can do this, guys. What we have to do is make sure that everything on the outside gets multiplied by everything on the inside. So the 5 has to get multiplied by m and by negative 3. So 5 multiplied by m is 5m. 5 multiplied by negative 3. If you don't know your negatives very well, guys, stick it in your calculator. That's minus 15. And that expression there is our solution. Part C, find the value of 6x add 3y when x equals 5.2 and y equals 0.4. So this is a substitution question. We've got an expression that has x and y in there, but they tell us the values of x and y. So we're going to substitute those values in. So we have 6x, but instead of x, we're going to write 5.2 plus 3y, but instead of the y, we're going to write 0.4. And I'm going to pop that in my calculator. So 6, 5.2 plus 3, 0.4. I've put it in exactly as I've written it on my paper, guys. And that tells me it's 32.7. Part D. Solve. E divided by 2 subtract 4 is equal to 6. So E over 2 subtract 4 is equal to 6. So the first thing I'm going to do, guys, is I'm going to eliminate that fraction. I'm aiming to solve for E, so I want to isolate E. I don't want it to be in a fraction. So this is E divided by 2. The opposite of divided by 2 would be to multiply by 2. So when I multiply the left-hand side by 2, that cancels out my fraction. It leaves E. But this negative 4 needs to be multiplied by 2 as well. A lot of people forget this. So 2 times negative 4. Again, use your calculator if you're not comfortable with negatives. So I've dealt with the left-hand side, but as always, I need to do the same to the right-hand side to balance the equation. So I'm doing 6 times 2, which is 12. Now I have a one-step equation. I'm aiming to solve for E, remember, so I'm aiming to isolate E. So the next thing I'm going to eliminate is the subtract 8. So the inverse of subtracting 8 is to add 8. So when I add 8 to the left-hand side, that cancels the 8 out. And then when I add 8 to the right-hand side to balance the equation, that tells me that E is equal to 20. Part E, the rectangle below has a length y and a width x. So length y, width x, not drawn to scale, so we can't measure anything directly from it. 3 rectangles congruent to the one above are arranged without overlapping to create the large rectangle below. Again, not drawn to scale. So 3 rectangles congruent to this one, so exactly the same as this, have been put together with no overlaps to make this big rectangle. Find an expression for the perimeter of this large rectangle in terms of x and simplify your answer. Okay, so I'm going to start by labelling what I know from here onto this diagram. So any lengths we're going to label as y, guys. Okay, so this is y. Let me get my ruler to make it clear. Oh, wobbly line did not mean that. This is y. And this is y. Okay, so I've labelled any lengths. I've only labelled the ones that are on the outside because when I'm working with perimeter, I'm working with the outside of the shape. We might need to use the inside to help us, but for now I'm just labelling the outside. Okay, and then I know that these widths are equal to x. So this is x, this is X. And then down here, this is X. And this is also X. Okay. So we have all of the sides of the outside of this rectangle labelled with an algebraic value. However, it wants an expression for the perimeter in terms of X. So when we add these all together, we don't want any Y's in there, guys. So we need to look at our diagram a little bit closely. So we know with a rectangle, we have two pairs of parallel sides. This side and this side are parallel, and are equal. This side and this side are parallel and are equal. So that tells us that Y is equal to 2X. So I'm going to pop that here. Y is equal to 2X. So now instead of having Y, I'm going to write 2X. So here we've got a Y, here we've got a Y, and here we've got a Y. I'm going to change those. So that's 2X, 2X, and 2X. Now, when we look at this, I have all of the dimensions around the outside of this triangle in terms of X, which is what it's asking for. So I'm going to add those all up now to get my expression for the perimeter. So we are working with X, and I'm going to tick it so I know I've used that one, plus 2X, plus X, plus 2X, plus X, plus X, plus 2X. And by ticking it, I know that I've included that side and I'm not using any more than once or whatever. Okay, so let's add these together. We have 1X. And I'm going to use my calculator to keep track here. So we've got 1X plus 2X plus 1X plus 2X plus 1X plus 1X plus 2X. So we have 10X in total. So the perimeter is equal to 10X as an expression in terms of X. Question 11. Fahima has a sack that contains a number of identical balls of different colours. The table below shows the probability of randomly choosing a ball that is red, green, yellow or blue. So this is the table here. Part A. Fahima claims there are other balls that are not red, green, yellow or blue in the sack. Explain why she is correct. Okay. So, if there are other balls that aren't red, green, yellow or blue, then we would have another value that we could include in this table. Now, what we need to remember is probabilities must sum to 1. Okay, probabilities have to add to 1. So, let's see what these add up to. So, 0.32 plus 0.46 plus 0.1 plus 0.12. Remember, I'm writing down everything that I'm doing in my calculator, so if I enter it wrong into my calculator, they know I was trying to do the right thing. Right, they all add up to 1. So she's incorrect. There can't be any other colours in there because probabilities sum to 1. Part B. A ball is chosen at random from the sack. Calculate the probability that the ball is green or yellow. Okay, so we're dealing with a probability that the ball is green or yellow, which is 0.1. So with the or means we are adding, guys. So the probability is 0.56. Part C. Fahima uses the sack of balls for a game at her school fair. In the game, each person pays 50 pence to choose a ball at random from the sack. The ball is then returned. The player wins a prize worth £2.95 if a blue ball is chosen. 150 people each played the game once. How much profit would you expect Fahima to make? You must show all your working. Okay, so we're working with the blue ball here. So I'm going to, from the table here, the probability of a blue ball is 0.12. So the probability of winning is 0.12 because to win they need to pick the blue ball. 150 people each played the game. Okay, so they played it once. So each person plays 50p. So I'm going to do 150 times 50p So that's 7,500 pence, which if I divide that by 100 is £75. So she makes £75 from people paying to play. But we need to figure out how much she would pay out. So we need to figure out an estimate for how many people would win. So how many people are going to pick a ball that's coloured blue out of this sack. So the probability is 0.12. 150 people play. So 150 multiplied by 0.12 is equal to 18. So we expect 18 people to win. If they win, they get £2.95. So that would be 18 lots of £2.95 she would have to pay out. So that is £53.10. She makes £75 from people playing. She would pay out potentially £53.10 to winners. We want the profit, so we want the difference between those two. So we're going to do 75 subtract £53.10. Which is £21.90. So we'd expect her to make £21.90 profit.